Welcome students. In this video we are going to see how to measure the flow using a rotameter and how to calculate the percentage error in the rotameter. So this is the experimental setup. Water will be coming through this pipe. So water will be coming through this pipe and then it will be entering the rotameter. After flowing through the rotameter, it will be entering the collection tank. So this is the collection tank and this is the rotameter. In the extreme left also you are having a flow meter. A rotameter is a flow measuring instrument in which you can measure the flow rate in liters per minute. This consists of a enclosure, transparent enclosure. Inside this enclosure you can find a transparent tube. So this is your transparent tube, and at the bottom I am having a float. So this is the float. So when no flow of water takes place, the float is at the bottom position, and if the water is flowing through the rotameter, the float gets lifted up. See in the second figure. So in the second figure, you can see that the float has risen up due to the flow of water from the bottom. So this is also a flow meter. In this you can read the quantities inside this window. So in this experiment we are going to determine the percentage error in a rotameter. So to perform the experiment we will be requiring a rotameter, a measuring scale and a stopwatch. The schematic diagram will be like this. The water will be coming from a tank. It passes through a main inlet valve. So P is the main inlet valve and Q is another one valve. If you open this inlet valve, water passes through this pipe from the tank to the rotameter. So water will be going like this and then it will be entering the rotameter. So due to the flow of water, this float gets lifted up and the water will be entering from the bottom, and the space provided it will go and then it will come out of the rotameter. The water after passing through the rotameter is collected in the collection tank. So in this experiment you have to note down two quantities. One is you should note what is the rotameter reading. So rotameter reading you have to find. So rotameter reading you can see from the graduated scale. In the rotameter tube, near it you will be having a graduated scale. So based on the float position, you can tell what is the rotameter reading in liters per minute. Then you have to measure what is the time taken. The time taken for x centimeter rise in the water level in the collection tank has to be noted. Let us take for 5 centimeter rise in the water level in the collection tank. What is the time time. So the time can be noted using a stopwatch. So before taking the time readings, you kindly ensure that the outlet of this collection tank is closed. So this has to be closed, or else what happens is the level of water in the tank will not be rising. Whatever water is entering, it will be gone out. So to see the increasing water level, this outlet wall has to be closed, and then you have to note down the time taken for 5 centimeter rise in the water level. So I have taken 5 set of readings. For each rotameter reading, you have to note down what is the time taken. Then you have to calculate the actual discharge, and QR is the rotameter reading. So this is the rotameter reading in meter cube per second. Actually this reading is in liters per minute, that I am converting into meter cube per second, and finally I am calculating the percentage error. So I am taking the reading number 5. So for reading number 5, the rotameter reading is 45 liters per minute. So this 45 liters per minute has to be converted to meter cube per second. So I am dividing by 60,000. So how this 60,000? So that you can see here. So 1 meter cube is equal to 1000 liter. So 1 liter is equal to 10 power minus 3 meter cube. So 1 liter per minute can be written as 10 power minus 3 divided by minute, 10 power minus 3 meter cube divided by minute. So 1 minute is equal to 60 second. So I can rewrite this as 10 power 3 into 60, and the overall unit is meter cube per second. So to convert 1 liter per minute to meter cube per second, I have to divide by 60,000. In the sum I am having 45 liters per minute, so I am dividing by 60,000. So the actual discharge is calculated using the time that is noted. A is the area of the collection tank. The area of the collection tank is 50 into 50 centimeter. So to convert the centimeter to meter, I am multiplying by 10 power minus 2. The final result I will be getting in meter square. So the area of the collection tank is 0.25 meter square. I have taken the time for 5 centimeter rise in water level. So y is equal to 0.05 meter. Here I have calculated the actual discharge. Actual discharge is equal to AY by T. So when you substitute this, we will be getting 5 into 10 power minus 4 meter cube per second. See this discharge area A in the discharge formula, this area A is in meter square, and height y is in meter, and time is in second. Therefore I will be getting the value in meter cube per second. The percentage error in rotameter is calculated using the formula rotameter reading minus the difference of rotameter and the discharge through the rotameter and the actual discharge. So for both this discharge, I am calculating what is the difference. Then I am dividing this value by the rotameter reading in meter cube per second. So this value has to be multiplied by 100 to get the error in percentage. So the rotameter reading is 7.5 into 10 power minus 4, and the actual discharge is 5 into 10 power minus 4 meter cube per second. This is the rotameter reading in meter cube per second. So when you solve this, you will be getting 33.3%. So this is the graph that is drawn between the rotameter reading in liters per minute and the error in percentage. I will be getting a graph like this. So with the increase in the flow quantity, the error percentage also increases. Thank you, students.